This video is for 10 minutes review, 10 minutes summary for investigation 3A. There are three key points on in this investigation. There are transformation, absolute value equation, and how to read the graph. And let's go over first one. So key point one is the transformation, x comma y maps to. If you remember, this you read it maps to. X plus a, comma, y minus b, or y plus b. Let's look at this graph and let's find out the coordinates. So point T, the coordinate is -5, comma 4. And point I, the coordinate is 2, comma 1. And point R, the coordinate is -4, comma 0. And let's apply some rules, something like this, to these 3 points. So these are the original points, and let's create some rules. For example, let's say x comma y maps to x plus 3 and y plus, or let me do minus, for example, 7. Then we have to apply these rules to each graph. So in this case, x is -5. So we just replaced with -5 for t, and y is 4. So we're going to replace with y. So this will equal to -2, comma 0. So that's going to be the new points. So the new point will be let's just do other things first. For point I, so let's call this actually t prime, okay? Because it's a new that implies a new points. And here for I, so let's call it I prime. Will be x is 2 and y is 1. So I prime, the new point for I will be 5, comma -3. And likewise, R prime will be, we replace with -4. -4 plus 3. And the y will be 0. So R prime will be -1, comma -4. And if you plot these points, we'll have new, oh, my pen is not working. Okay, there you go. So the new point will be, t prime will be -2, 0. So it will be right here. That's -2. No, I'm sorry, that's 2, 0. That's right here. This is t prime. And I prime will be 5, -3. So 5, -3. That's I prime. And R prime will be -1, -4. So it's right here. And you see new triangles. And that's how you translate. Alright, so key point 2 is how to solve these absolute value equation, and again, absolute value is the distance, so the distance between whatever the point to 0. So in order to solve this problem, I want you to think about what number can you put if we remove this one, Obviously, it's either 5, positive 5, or negative 5. So this could be, so the answer, whatever the number you put, could be either positive 5 or negative 5. Okay? And whatever we put inside of that absolute value sign has to be equal to um, x minus 3, because that's the original problem. You know, that is in there, but we just took it away. So this has to be either x equals 3 has to be equal to positive 5 or negative 5. And you know how to solve each equation. Just simple equation. So if it's x minus 3 equals positive 5. So you just add 3 to both sides. So we have x equals 8 on this equation. And this equation, which is x minus 3 equals, that also could be negative 5. And you do the same thing. Then we'll have x equals negative 2. So the answer could be either 8 or negative 2. So when you see absolute value equation like this, you can almost always assume that the answer is, you have two answers. If that absolute value equals 0, then you only have one answer. And if you have negative numbers as a solution here, if this number is negative, then there is no way that we can find any, there's no solution, because what number can you put, for example, what number can you put over here if the answer is negative 5? There is no absolute value is a distance, so it doesn't really make sense to say the distance is negative. The final point of this investigation is how to read a graph. So this is the example from the textbook, and how do you read this graph? Right here, this is the original point, and this is the starting point. And the distance time graph, you always have time on a independent variable or horizontal line, because distance depends on time. That means time is the independent variable. So let's make some, let's analyze this graph. So if you look at the torus, it's just straight line. That means it's just a constant pace, and it's just going on and on and on. And on the distance time graph, the steeper the line is, the faster the object travels. So if you look at first part of it right here is very, very fast, because the line is way steeper than torus. But right here, it's flat. Flat line means in the distance time graph, that means that the object is not moving. So as you know, the hare is taking a nap or something. And then at this point right here, torus is overtaking hare, and the hare is going up. Hare is still sleeping, and torus is just keep going on a constant rate. And if you look at this, let's say this is the goal line, because this is the distance. The higher you go, the farther you are in the distance. So right here, I want you to look at this point and this point. I want you to compare these two. These two, the distance-wise, these two objects are on the same point. However, if you look at the look at the time, so this is gonna be the torus point, and this is gonna be the hare's point. So that means that the torus reached this point right here during this time. This is the tortoises, and this is the hares. The hare reached at the same point at this time, right here, right? So this means the farther you go on the horizontal line, that means longer you are taking. That means the tortoise reached the goal right there spending less time than Hare. So that means Tortoise reached the place faster than Hare. So that's the basic, that's how to read a graph basically. And that's how you can pull out some information.